We are now in 2.1 day 2, and we're going to talk today a little bit more about standard form and vertex form. Yesterday we converted from standard to vertex by finding the vertex just kind of by the old-fashioned method, sort of the quadratic formula style. But then today what we're going to do instead is we're going to go from standard to vertex form in a way that I'm guessing you were hoping would never come up again, and that's completing the square. But in this case, it's actually going to be a little bit easier to do, a little bit less time consuming than the method that we used yesterday, if you can believe that. We're going to do two examples. This is the first example. This one is the simpler version of completing the square. Then we'll go on to do one that's a little bit more complex. So one thing I want to remind you of is that with completing the square, there's a little formula that we use when we find the c term, and that is b over 2 squared. So we're going to use that again here and figure out how to complete the square, but we're not going to actually solve an equation here. We're just changing forms. So one step, you'll notice that there's just a number of 1 in front of this x squared, so we don't have to worry about there being that number there. We can separate that out. We can just skip that first step. But what we are going to do is, first of all, we're going to take the x squared, the first two terms, the x squared and the 6x, and we're going to separate that from this negative 13. We're going to put these in parentheses. We're going to leave a little space, but we're going to put the negative 13 out here. We're just sort of rearranging this whole setup right now. And so then we're going to try to find out what would make this a perfect square trinomial. You might need to go back and revisit completing the square from earlier on in the year, but if this makes sense to you, then we'll be okay. So we're going to try to find c. We're using this formula here. So for this problem, c is going to be b over 2, so that's 6 over 2 squared, which is 3 squared, so that's 9. So that means that we're going to fill in here. I'm going to put in a plus 9 right there because that's going to complete the square of this perfect square trinomial. But I can't just add 9. I have to also offset that. Now last time what we did was we put the plus 9 on the other side of the equation. But we don't want to do that here because we want y to be by itself. So another way we can offset this is we can just subtract 9 on the outside, and then we have an overall net addition of 0, and so the equation has remained the same in that situation. After that, what we want to do is simplify and factor. So the factoring pattern, if you remember, goes down to something squared when you're doing completing the square, and so I'm just going to take the square root of this one, put it first, square root of this one, put it second, and then in the middle goes the sign that was in the middle right here, so it's going to be x plus 3 squared. Then I do have to simplify that stuff, and so those two just add together to be negative 22, and so now we've got the vertex form for that first one. So that's actually pretty simple. It's only 2 steps. It seems to be a better use for completing the square than what we might have thought of it earlier on in the semester. That's a simpler version of changing from standard to vertex form by completing the square. I want to show you one that's a little bit more complicated now so that you're prepared for both. And so here's the second one. The main thing that makes this more complex is noticing the fact that there's a 5 in front there. Now I'm still going to take the first step the same. I'm going to separate out the x squared term and the x term. I'm going to put those together. And I'm going to leave this plus 12 out here. I'm just going to make that go out in front. So here's what's going to happen. I'm going to try to find the c value in here again, but I need there to be just a 1x squared in order for that to work. So here's the step that you're going to do second. Now it has to be second. If you do this first, it's going to mess things up, and you have to divide the 12 by 5, and that's not going to work very well. So here's what the second step is. So once you have this in parentheses, then let's factor out the 5 from there, get it out of the way, and we're going to leave inside x squared minus 5x, and leave a little empty space there. That plus 12 is still going to be sitting around out here. All right, now that that's taken care of, what we're going to do is complete the square inside this, just like we did before. And so that's our little C formula. So C equals, and this is going to get a little messy this time just because we're going to be working with fractions, but C equals, we're going to do B over 2 squared, and so that is going to be negative 5 over 2 squared, which then simplifies to 25 fourths. So we're going to add 25 fourths in here, like we did last time. We do have to offset that. Now you would think, okay, subtract 25 fourths, but there's a catch on this one. And the catch is that we've got a 5 out here, and if you think about what we would have to do if we were to get this all out in the open, we'd have to distribute. And so not only am I adding 25 fourths, it's like I'm adding 5 times 25 fourths. So if I've added that to the equation, then I have to subtract that much. And so that's going to go out here, and you'll put it as minus 5 times 25 fourths. And that's a sticky point to this complex version. That's what's going to trip people up the most when you're doing this type of problem. Once we have that, though, we can simplify. And the simplifying is actually a little easier than you might think. We do need to factor this one, kind of like we did before, where we have square root of this goes first, square root of this one goes second. Well, square root of 25 is 5, square root of 4 is 2, so that's 5 halves, which we saw up here anyway. And then there's a minus that goes in the middle here. Now, just to skip some of the details that you really don't need to see, if we make this into fractions with common denominators, that one ends up simplifying to, whoops, it's not plus, but it's going to be minus 77 fourths when all is said and done. So there's some complexities going on in there. Please ask about that one if you have questions on this. But this is the more complex version of completing the square from 2.1.